Okay, so let's now proceed into some examples of reinforcing loop. Reinforcing loop actually is something which motivates or enhances its influence on another action. So in this particular example, birth encourages increase in population. And that increase in population also encourages more birth. So let's look at it this way. If there are more people born, then it adds to the population. And if there are more people in the population, more people will be capable of giving birth. Hence, it motivates or it enhances the process, leading to the further increase in population. So, in this picture also, you'll see there are two diagrams. First is the structure of the reinforcing loop, in which we see the causal loop diagram, and at the same time we would see how that particular relationship between birth and population is seen or behaves across time. So, if you look at it this way, as time goes by, the population also increases following this particular curve. In another example, we could see how the bank balance or the money in the bank increases through time as there is an increase also in the earned interest. We all know that interest rate is fixed. However, the earned interest would depend also on the amount of bank balance. So the larger the bank balance, the larger would also be the earned interest. So in this particular structure here, we see that it's a reinforcing causal loop diagram, and its dynamic behavior is seen as increasing exponentially across time, which is a good thing in this particular case. But sometimes reinforcing loops also creates what we call as a vicious cycle. In this example here, we see on the left side is deforestation. So as deforestation increases, on the right side we see that soil erosion also increases. And as soil erosion increases, it also leads to more deforestation. For example, soil erosion leads to landslides, which causes some trees also to collapse or being uprooted, hence leading to what we call as deforestation. And this type of deforestation also enhances more or motivates more soil erosion, and the cycle goes, which is what we call as a vicious cycle. Now, let's look at balancing loop examples. So in this case, we see the relationship between predators and prey. This refers to their population. As we have more predators, eventually this leads to the decrease in the number of prey. Why? Because more predators, it would eat more prey. Hence, the population of the prey declines. And if there are lesser prey, what does it mean? It means that some of the predators would also suffer. Some would die of starvation. Some would, of course, survive because they are better at hunting. But eventually, it creates a negative effect on the predators. And when there are lesser predators now, the number of prey also would increase. Why? Because there are lesser organisms that would hunt them. Hence, they would be able to survive and hence be able to reproduce. And across time, when they become larger in numbers, the lesser number of predators would also increase later on because they have more prey now to hunt. So if you look at this structure here, which is a balancing loop, and then look at the right side, which is dynamic behavior, we see that these two populations seems to relate to each other in a balancing equation. Meaning, as we see this graph here, the blue line represents the prey and the red line represents the predator. And as you can see, we call this as an oscillation, wherein we can actually see a balancing act between these two organisms. When there are more prey, the number of predators also catch up. However, when there are more predators, there would be a certain decline in the prey. And when they decline, the predator also decline in number. However, after there's a decline in the predators, in terms of population, eventually the prey also increases in population. And eventually, as it goes on and on, across time, the same relationship in terms of the number of prey and predators goes on across time.